Now, coming to the determination of instantaneous velocity in graph. So let us choose a point here, which is x along OA. And if we were to find the instantaneous velocity, we would come to the conclusion that instantaneous velocity in the graph at the point x, oops, my bad, is equal to average velocity from 0 to a. Yes, I do understand that you have a question here. Give me a couple of minutes. I'll come right into it. Okay. Which also would mean that average velocity from B to C, right, from B to C will be the same as instantaneous velocity at this point Y along BC. And so would be the case from Z being a point on CD, velocity average from C to D will be equal to velocity instantaneous at this point Z. So velocity instantaneous at Z will be equal to velocity average from C to D. Okay. The question here is, how is the case that velocity instantaneous at a point is equal to velocity average? So let us consider the point x here, which is along OA, right? So x is a point along OA, and to reach A from O, we have to run like this and rise to A. Okay. So let's maybe call this as O X A. No, we can't use X. Maybe O Y A. And it passes to the point X here. Okay. Now, how do we find velocity instantaneous at, my bad, this is not A, it should be velocity instantaneous at X, velocity instantaneous at X, velocity instantaneous at X. So if we have to find the instantaneous velocity at X, we should draw the tangent first at X and then find the slope of it. One more time. How do we find the instantaneous velocity at X? We first plot the point X, draw a tangent there, and then find the slope of it. Now, the graph is not curved in nature here. I mean, the graph is, it doesn't look like this. It doesn't look like this, a curved graph, wherein you can actually find a point here and then draw the tangent, find a point here, draw the tangent, right? This graph is instead a straight line graph. This is moving up like this. So along the straight line, just give me a minute. Along the straight line OA here, the tangent is the same, which means OA is actually the tangent for all the points along OA. Therefore, slope of tangent at X is actually equal to slope of OA. And what is slope of OA? Slope of OA is the velocity average from 0 to O to A. And therefore, instantaneous velocity at X is equal to average velocity along OA. It's becoming way too much, isn't it? I can understand what you're going through right now. But then please be patient. It's a very humble request. Write down things along with me. Once we begin a rid of solutions, which is just hardly 5 or 6 questions away from this, the discussion of this first chapter here, you'll then understand, oh, this is the reason why we had to discuss graphs in detail with for that one single question. Okay? Pause yourself. Think of this. And if you have given it some time to think, let's try to write down the slope for this point here, y. So y is a point which is on the segment BC, right? So if we were to write instantaneous velocity at y, that will be equal to what? Will be equal to slope of tangent or chord. Exactly, that will be equal to slope of tangent at y. Then we'll have to drop a tangent at y. How do we drop a tangent at y? It just goes like a line segment like this, which is BC, which is equal to the slope of tangent, my bad, which is equal to slope of the line segment BC. And what is slope of line segment BC? Exactly, it is the average velocity from B to C, which is equal to the instantaneous velocity at y. So look at the hierarchy of concepts that we're learning. We first learned what is slope, then we saw slope of a chord, then we saw slope of a tangent, applying the slope of a chord to find average velocity, applying the slope of a tangent to find instantaneous velocity, a couple of examples, and then the actual question, and combining all this to solve the Edo questions or the IIT advanced questions. Okay, so that's what we're trying to do. Okay, now having said this, there are a couple of things in addition to be discussed here, which is a bit extension of your maths into the graphs here. Now, before you watch the rest, I would suggest you go through limit and continuity and differentiability of class 11th maths. Okay, just glance through the pages, pause it, and then come back. Yeah, maybe maybe take a break. I do understand that. Yes, so you know, uh, pause the video, take some fresh air, open the book, just glance through it, and then come back later. Okay. Invincible is untouchable. Bottom of all the